Okay, so this is Dr. Sushila, and we are continuing the second lecture in this course on AI. So we were talking something about the history of AI. So let us see when AI, artificial intelligence, was actually started and how it evolved over time. Okay, so you find that you can say the early beginnings was somewhere around 1943. Okay, so you have the McCulloch and Pitts model. Okay, so that is like the Boolean circuit model of the brain. Okay, so that is where actually you could call them the early beginnings. And in 1915 you have the Turing machine. So Turing machine is now the first starting of computers basically. Okay. And in 1956 they had what is called the Dartmouth meeting in a place where different people who are working in some similar areas met, and they coined the term artificial intelligence at that point in time. Okay, so the name was adopted for this particular area. Okay, and you find that in the 1950s there were a lot of programs which came up. For example, um, many game playing things. For example, the checkers, chess programs, the early startings of these were started in the 1918s, and Samuel actually came up with a series of checker programs, each one better than the other, right? So those, and you have what is called the logic theorist, which was started by Newell and Simon, right? So these were, it's something like a general problem solving method, the logic theorist. So these were what came up in the 1950s. And what happened is that in 1955 to 65, like I've written, there was a lot of enthusiasm, and people thought that, wow, we can do a lot of things using AI. We can, even find new theorems and do a lot of things. But and at this time, you have Newell and Simon coming up with what is called the GPS, or the General Problem Solver, and you have Gellertner, who came up with the geometry theorem prover, and like I said, McCarthy started the Lisp program in 1960. So what you found that was, at the beginning you had a full Lisp machine itself. The entire machine, one whole computer was used only for Lisp. Now you find that Lisp is one of the many languages which are found, right? And there was great enthusiasm. People thought that AI is doing so well, we'll come up with a lot of things. We will, defeat the grandmaster in chess, and everything in the world will be solved by using AI, etc. So there was great enthusiasm, but what happened is that around 1966, after that, people found that it wasn't really living up to that. Okay, so okay, it was working for small programs, etc. But when you come to real practical problems, you found that many of them were really intractable. Okay, if you use the AI system to solve it, it would have taken too long, and it was not practical to use it, etc. And you found that neural networks were not working well. Okay, because neural networks, people hadn't discovered multiple layers, right? You just had the input and you had the output, and so it was just a single layer neural network which was used at that point, and it was not possible to use it for non-linear systems. So what was found is that the AI problems were not really working so well at that point in time. So then they went into things like knowledge representation. Okay, so you find a system in which you represent a whole lot of knowledge in it and use that knowledge to get out whatever you want. So this is where the expert system started. For example, you have a system where you enter all the rules, okay, for say diagnosing some disease, and you give the symptoms of the patient to that, and it should be able to tell you whether the patient has that disease or not. Okay, so it was used for diagnosis, medical diagnosis. It was used in many fields, right? So there were some very popular expert systems like Dendral, Mycin, etc., which came up in the 1970s sometime. But they were mostly knowledge based, like you have to enter a lot of information into it, and then it just had rules, if then rules. Okay, so the if part is satisfied, then the then part is satisfied, so something like that. And it was only in 1980s that you found machine learning came up, right? Neural networks again returned to popularity because they discovered you could have one or two hidden layers, right? So when you have hidden layers, you can have a nonlinear system, okay, which will be able to solve more complex type of problems. So neural networks came back. There was a lot of advances in machine learning algorithms. A lot of machine learning algorithms came up, etc. So when machine learning came up and neural networks returned to popularity, then again AI took off. So you find in 1990s, they spoke of uncertainty. So how do you handle uncertainty? So when you handle uncertainty, you also have things like decision theory, utility theory, all these things came up. And what happened is that AI became a science. Okay, in other words, it was actually done in a very mathematical way, and you were able to get very good results using that, right? So you find integration of learning. So the machine learning algorithms which were discovered earlier were used, and learning was integrated. Reasoning, so representing things using logic. Earlier there were other methods of representation when expert systems first came up. So we spoke about frames. Okay, so there were frames, there were graphical methods of representing knowledge, etc. So a lot of methods were there for representing, which were not very practical at that point in time. So they came up with different methods of knowledge representation, reasoning, okay, and you find that AI methods were used in vision, language, data mining, lot of different areas, applications, okay, and very successfully used. So AI came up after that, right? So here this is what was done at the Dartmouth College, where they met in 1956, right? 1955. So you had people like McCarthy, Minsky, Rochester, Shannon, etc. We spoke about a few of them earlier. So all these people were those who were involved in this field. So they all met, okay? And this is what they declared. We propose that a 2-month, 10-man study of artificial intelligence be carried out during the summer of 1956 at Dartmouth College in Hanover, New Hampshire. The study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. So that was the beginning of AI basically, and the term artificial intelligence was actually coined at that point in time basically. So let us look at some application areas. So obviously artificial intelligence can be used in almost any field, right? So we'll look at some specific fields where artificial intelligence have been used, and you find that it gave very good results. For example, business, financial strategies, okay. So if you have particular business, okay, what are the strategies that can be used so that it can make profit, right? So you can have an expert system which gives advice to that. And you also have things like stock markets. So it can give advice on which stocks to buy and which stocks to sell, and all those type of things, right? So in business, it was very heavily used. Engineering, so engineering to check the design. Okay, so it was basically the expert system was used for designing computers, no? So IBM, or I mean, I'm not sure about whether it was IBM. Some organization was using expert system to design the computers, to offers suggestions to create new products, etc. Right? Manufacturing, so it can be used in assembly, inspection. So inspection, quality inspections, it can be used, right? Maintenance, so to check whether it requires maintenance or not, assembly, all these. Mining, where the conditions are dangerous and it's not recommended that human beings go there, you can use robotics and you can use AI systems, etc. Hospitals, it's used a lot, right? So monitoring, diagnosing, prescribing, it can be used to see what is the best method of looking after a patient, right? And even things like predicting how long the patient is going to stay in the hospital, okay, and things of that sort. And education. So in teaching, it's very useful. So what you find in teaching is that you can use the computer to carry out the teaching and also evaluate the student, right, and see whether the student is improving or not, right. So you can automate a lot of these things which is now being carried out. Maybe even evaluate things like compositions or essays, etc., which had to be done only by human beings before. Maybe it could be done by an AI system, right? And in household, advice on cooking, shopping. Okay, so everybody knows that nowadays you get these devices which help you to do these things, right? You can ask what is the weather, or what would you recommend, etc. So that type of thing. Farming, actually, in agriculture, AI is used a lot. So you can see, you can have helicopters where you take the layout of that place, and then you can see whether the crops are coming well, and you can use that to prune the trees, selectively harvest, see where pesticides need to be put, all those type of things. So AI is used a lot in farming, actually. Okay, so nowadays when you see, you find that AI has improved a lot. So this slide basically tells you how it has improved, right? So you find that speech recognition nowadays is very accurate, right? So what you're doing is you're giving the waveform to the, you have hidden Markov models. Nowadays you use deep learning models, etc., and you get very accurate results in speech recognition. Planning, you have wonderful planning systems. Okay, so you have planning systems used for scheduling of factory work, space missions, etc. So in space missions, actually, it plans and it monitors the plans, and if there is something going wrong, it replans. There's it's become very good, the planning which is done. And of course, dealing with uncertainty. Okay, so probabilistic reasoning is used. You have things like Bayesian belief networks. You have other types of reasoning. Okay, non-monotonic reasoning, etc. So dealing with uncertainty is something which is done very well nowadays as compared to earlier, right? Decision theory and utility theory has been actually almost perfected, right? So what happens is you need to finally take a decision on what is to be done. So if you have different actions that are possible, you need to see which action is the best action that you need to take, okay? And if there are, say, more than one action which can be taken, you can use the utility theory, and the utility theory will tell you which is the best action. Okay, for example, if I want to travel from, say, point A to point B, okay, there may be, say, 2 or 3 routes which will take the same time, right? So which route do I take? So you may want to use a route which is more comfortable, okay, maybe one road is very bumpy and you have another road which is less bumpy, etc. So in this way, you can use a utility theory. Okay, so utility theory is something like the satisfaction or the happiness factor, okay, something like that. So that is the utility theory which will actually give you a value, say between 0 and 1 or something, which will tell you the utility of that particular action, and then you can choose which action is the best. You also find that there's a lot of improvement in robotic, computer vision, machine learning, knowledge representation. Okay, so there are a lot of, for example, knowledge representation, some of the old methods have just gone out of use. For example, things like frames, etc. So you find lot of new ways of knowledge representation which are much more practical, and with the improvement in computers, okay, knowledge representation has also improved a lot, okay. So now you find that there are a lot of AI systems, especially the commercial ones. You find lot of commercial systems, AI systems, okay. And another important thing is the deep learning. So as soon as deep learning came along, you found that deep learning was giving very, very accurate results as compared to the other methods. So you found that there was a big boost to AI, okay, because AI started giving very good results, because the results you were getting out of deep learning systems where you don't need to even carry out things like feature engineering, etc. So you found that it was much easier to use deep learning because you can just dump all the data that you have as input into the deep learning system, and the deep learning system itself will be able to pick up which is the important features in that. So you found that there's heavy use of probability theory, decision theory, statistics, logic, different types of logic. So probability theory mostly because there's a lot of uncertainty in what you're doing. Decision theory, you need to take decisions. So you have area called decision theory, and that is made use of extensively over here. Lot of statistics and logic, of course, is a very important aspect here, okay. And what is used is something like, say, propositional logic, and when you need to take care of time and when you need to take care of space, okay. So for example, maybe location is also important, okay. So there are different ways in which you can make use of the change in location, okay. So you have things like modal logic actually takes care of the change in location, whereas temporal logic takes care of the change in time, okay. So the time at which something happened, right, so that when an event occurs, so that time also is taken into account. And fuzzy systems, okay, so we will study something about fuzzy systems. So fuzzy logic also is a very important aspect of logic which is used over here. So recent AI systems make use of all these different concepts, right. So here we'll talk about some everyday use of AI in different places. So if you come to the post offices, you find that they use automatic address recognition. So when you send a letter somewhere, so it tries to automatically recognize the address and sort the mail according to that, right? If you go to the banks, you have automatic check readers, you have signature verification systems, automated loan application. So it classifies it and tells you whether the person is fit to get a loan or not, etc., right? So all these things are done in the bank. Then when you come to customer service, for example, if you have airlines and the airlines needs to, you need to book tickets in the airlines, etc., you have automatic voice recognition. So you can talk to the automatic voice recognition system, which will help you to book tickets, right? So everything is done in using natural language processing. You can talk in English and the system understands what you're trying to do, and then it helps you, etc. Then if you come to the web, the web will be able to identify from your surfing what is your age, what is your gender, location, etc. And another important is the fraud detection. For example, credit cards, when you apply for a credit card, or if you are using a credit card and if there is some fraud, etc. So detection of fraud, right? That's very important. Digital cameras, automated face detection, right? So whatever is captured in the digital cameras, you use automated face detection, etc., and focusing and improving the image, etc. And computer games, right? So in computer games, lot of we have seen a lot of computer games, like you can play chess, you can play a lot of games, right? Um, so in all of them you have AI systems which are being used. Okay, so this talks about the translation, right? So you have the what is called the machine translation. So machine translation is actually understanding the sentence in a particular language and converting it to a sentence in another language, right? So now language understanding itself is very difficult because it's ambiguous, right? So we can understand because we know the situation around the place, right? There are a lot of things which go into it. There's a lot of ambiguities. The same word will have different meanings. You have things like similes, you have metaphors, you have personification, so many things which are going on, right? So it's difficult for a computer to understand. For example, if you see a machine translation which was done at some time, this actually is a very well-known translation which was done. So the English sentence says, the spirit is willing but the flesh is weak. And the Russian translation said, the vodka is good but the meat is rotten, right? So you find that there was a totally wrong translation that was done. So you need, it's very difficult to do machine translation. But what is happening is that there are many commercial systems now, okay? So they make use of dictionaries, grammar models, and lot of machine learning algorithms. So they use machine learning techniques and deep learning techniques. So what do you mean by black boxes? That you look at earlier, translations and you make use of those, get to do the translation now, basically. So these are, this is machine translation, okay. So the machine translation is done if you go to the internet or if you go into YouTube, etc., and if you look at the comments that are made and in so many other places, you can translate from one language to another language, right? So you can also, if you go to the news, you can translate from a local language. For example, suppose it gives out the news in Kannada to me, right? Because I'm from Bangalore. I can ask it to translate that into English and I can see the news in English. Of course, it's not completely 100% good, but it's giving, it does give a good translation, basically. Okay, so this is in games, right? So in games you find that what is the advances in games. Okay, so in 1950, Shannon published a paper on how the computer can play chess. Okay, and the chess programs kept improving after that. And 52 to 62, Samuel built checkers programs, different checkers programs, right? And in 1957, Newell and Simon predicted that the computer will beat the chess champion in 10 years, right? But what happened in 10 years is that it was good enough to achieve a class C rating, okay? And it was in 1994 that computer program became the world checkers champion basically. And in 1997, Deep Blue checkers program actually bet Kasparov, who was that the grandmaster at that particular time in chess, right? And in 2007, checkers is solved, like they say. So what you find is that over the years there was an improvement in game playing basically. Okay, so let us look at the difference between artificial intelligence and conventional programming. What is the difference, right? So if you look at the processing, you find that in artificial intelligence, it's mostly symbolic processing, okay? Whereas in conventional programming, it's algorithmic, okay? And what should be the input? The input can be incomplete in the case of artificial intelligence. So it doesn't always expect you to give everything in a complete fashion. Whereas in the case of the conventional programming, everything should be complete, right? Input must be complete. Search is algorithmic in conventional programming. In fact, there's no search in conventional programming. Explanation is provided in the case of artificial intelligence, okay? And in the case of artificial intelligence, you talk about knowledge, whereas in the conventional programming, you talk about data and information, okay? And structure, you have separation of control from knowledge, okay? Integrated with the knowledge in the case of conventional programming. So, what you find is modularity is more in the artificial intelligence. So, these are some differences which you find in the two, okay. So, what is the type of computing that you have? Okay, so in the case of conventional computing, you use conventional computer software where you give a logical series of steps to reach a conclusion. For example, if you want to say carry out statistical analysis or something, you have to give a step by step procedure, okay. So if this is A and this is B, this is C, this is D, then you do this and this is the correlation that you get, etc., right. So you have to give. Whereas in AI software, you use a technique of search and pattern matching, okay. So that's the difference between the two. You don't have to, you give the computer the problem, not the steps to solve it basically. Okay, so what are the pros and cons of the human intelligence and the artificial intelligence? So human intelligence, of course, we know what is human intelligence, okay. There's a lot of creativity, common sense, judgment, intuition, right, critical thinking, plausible reasoning, etc. And in the case of artificial intelligence, you find that there is a fast response, okay. So the intelligence which is there in artificial intelligence, you use logic or whatever you are using, you find that it works much faster than the human intelligence, okay. And it can be used to capture some of the human expertise, okay. For example, if you take expert systems, you find that the doctor's expertise or the rules of thumb or the heuristics which they use can be preserved, okay, captured, and it can be put into the system, right. And what are the cons? Okay, so humans, of course, we know they are fallible, they make mistakes, they have limited knowledge bases. In other words, how much can we store in our brain, right? We can't really store that much. But the machine can store a lot of knowledge, right? That's the difference. And another thing is that the human being takes a lot of time, okay? So it's very slow in the brain as compared to computers. Whereas if you take the artificial intelligence, there's no common sense, okay? And to deal with mixed knowledge is difficult, okay? There may be knowledge of different types. So how do you make use of that, okay? And you have things like ethical concerns, legal concerns. So ethical concerns, of course, all AI systems have ethical concerns. So we'll talk about ethical concerns later on or towards the end of the course, basically. Okay, so if we look at if we want to compare, okay, our brain with the computer, what are the differences between the brain and the computer? So what you find is that in the brain you have the neuron, which is called the nerve cell. Okay, so that is the basic information processing unit, basically. Okay, so we have like 10 to the 12 neurons in the human brain. Okay, and we have a connection between different neurons by what is called synapses. So there are 10 to the 14 connections between neurons, and the cycle time is 10 to the power of minus 3. Whereas if we look at the computers, you have 10 to the 8 transistors per CPU, okay. Supercomputers can have hundreds of CPUs, 10 to the power of 12 bits of RAM. And cycle time is order of 10 to the power of minus 9, which shows that the computer is much faster if you look at the cycle time, right? But the brain is actually a massively parallel system. So here, taken from Russell and Norvig, you see that if you look at the personal computer and the human brain, you find that the personal computer doesn't do well when it is compared to the human brain, right? But when you look at the supercomputer, you find the supercomputer is coming closer and closer to what the brain can do, okay? Except that the cycle time, okay? So cycle time of the human brain is very slow as compared to computers. That's the difference over here. So we'll stop the second lesson at this point in time.